Today, we're pulling back the curtain on the invisible engine that powers so much of our digital life, Apache Kafka. And I know the name might sound a little dry, but trust me, this thing is an absolute powerhouse. Let's get right into it.
All right, let me kick things off with a question for you. What do streaming your favorite show on Netflix, booking a ride with Uber, or scrolling through your feed on LinkedIn, what do they all have in common?
The answer? Well, it all comes down to scale. Mind-boggling, massive scale. Just think about it for a second. Every single click, every view, every message you send, that's an action. These platforms have to process millions, even billions of these actions every single day. And the whole system has to work perfectly, in real time. That is a huge technical challenge. To really get why this is so tough, we've got to rewind a bit and look at how things used to be built and why that old way just completely falls apart when you try to scale it up. So, check out this old school setup. You've got one part of your app, let's call it Service A, and it needs something from Service B. Simple enough, right? So it just calls Service B directly and waits. But what if Service B is having a bad day? What if it's slow? Or worse, it just crashes? Bam! The entire chain reaction grinds to a halt. The user's request fails, and they're just left looking at a frustrating error screen. Engineers have a name for this, a single point of failure. It's like a chain. If just one link snaps, the whole thing is useless. And you can't just throw more servers at this problem. The fundamental design itself is broken for the kind of scale we're talking about today. Thankfully, some brilliant minds came up with a much, much smarter way to handle this. Enter the message queue. So what on earth is a message queue? Think of it as a trusty middleman. It's essentially a buffer that sits between all the different services, letting them communicate asynchronously. And that word, asynchronous, that's the magic ingredient here. It means they don't have to talk to each other at the exact same time. Let's make this super simple with an analogy. Imagine you're at a photo lab. Instead of standing there awkwardly waiting for your pictures to be developed, you just drop off your roll of film. In our tech world, you or the service creating the task are the producer. You've created a job and you're just dropping it into the queue. And then, on the other side, you've got the lab technicians, our consumers. They can just grab your film from the to-do pile whenever they're free. See the genius here? You and the technician never even had to talk. You, the producer, don't care if the consumer is totally swamped with work. You just drop off the job and you're on your way. This is called being decoupled, and it's a total game changer. Okay, so this whole message queue idea is already pretty powerful. But then a technology called Apache Kafka came along and basically put the entire concept on steroids. Kafka, which actually started at LinkedIn, is way more than just a simple queue. It's often called a distributed event store and a streaming platform. Whoa, okay, what does that even mean? It means Kafka doesn't just pass messages along and then forget about them. Nope, it stores them, like in a permanent, unchangeable logbook, almost like a database. And it allows applications to process massive streams of these events as they're happening in real time. Let's really nail down this difference. A traditional queue is often like a temporary inbox. Once a message is read, poof, it's gone. But Kafka is like an indestructible flight recorder. Events are stored for the long haul, and multiple different services can come along and read them, or even reread them, whenever they want. It was built from the ground up for the insane amount of data that companies like Netflix or Uber deal with every single second. All right, so how does this beast actually work? Let's pop the hood for a second and take a quick look at the core parts that make up Kafka. First step, the most basic building block, the message. This is just a single piece of data. You can think of it like one row in a spreadsheet. It's got a key, a value, and some other bits of information called headers. So where do all these messages go? Well, they get organized into topics. A topic is really just a name for a category of messages. It's super simple. Think of it like a folder on your computer. You might have a topic for user clicks or another for new underscore orders. Now, here is the real secret sauce behind Kafka's incredible scale. Partitions. Each topic isn't just one giant single list. It's actually split up into multiple partitions. This is what allows Kafka to spread all that data, and the work of processing it, across a whole bunch of different servers. This is how it can handle literally trillions of messages without breaking a sweat. And finally, let's meet the cast of characters. You've got producers. Those are the applications that are writing messages to a topic.
Then you've got consumers, which are the applications reading messages from a topic. And this whole show is run by a cluster of servers, which are also called brokers, that all work together to make sure everything stays up and running no matter what happens.
Whew, okay. That's enough of the technical deep dive for now. Let's bring all this back down to earth and see where people are actually using Kafka in the real world. As you can see, it's pretty much everywhere. It's used for everything from processing mountains of log data to powering those eerily accurate real-time recommendations you get on streaming sites. But I want to zoom in on one of these because it is a perfect example of just how transformative Kafka can be.
And that is Change Data Capture, or CDC for short. I know, the name sounds kind of boring and technical, but the idea behind it is nothing short of revolutionary for big companies.
So here's how CDC works, and it's brilliant. Imagine you have a central database. In the old days, every other system in the company would have to constantly poke that database, asking, hey, anything new? Anything new yet? It's super inefficient. With CDC, you have a tool that just watches the database's internal log. The moment anything changes, a new user signs up, an order is updated, the CDC tool grabs that change, packages it up as a Kafka message, and sends it out. Now, any other system, the data warehouse, the search engine, the analytics team's dashboards can just listen to that Kafka stream and update itself instantly. It's like creating a central nervous system for the entire company's data. And that really brings us to the big picture here. Technologies like Kafka are making it possible for data to flow instantly, like electricity, through every single part of a business. This isn't just some small improvement, it's a fundamental shift. So the real question we're left with is, now that this is possible, what incredible new things will be built on top of it? What's next?